Hello, sixth grade. How's everybody doing? Good to see you. Today we're going to start something new. So I want you to think about three-dimensional figures. So we have been working with two-dimensional figures when we were finding area of parallelograms and trapezoids and triangles, and then we put them together in compound figures. Well, today we're going to start thinking about three-dimensional figures and how they differ from two-dimensional figures. Well, when you see 3D, it means three-dimensional. When you see 2D, it means two-dimensional. So obviously a three-dimensional figure has an additional dimension to it. So in two-dimensional figures, we had ways to measure lengthwise and height, right? But now we're talking about adding a third dimension, which gives it depth, okay? So here's some examples of three-dimensional figures. Now, these all have very specific names, and we're going to talk about some of these today and see what the differences are between them, okay? So you should be taking notes in your geometry and measurement journals, and if you've run out of space, I could understand that. You just need to add some pages, okay? So, and feel free at any point to pause the video so that you can take a little bit of time and draw the figures, because they are a little bit tricky to draw, okay? So let's start with kind of a basic three-dimensional figure called a cube. Now you're probably all very familiar with cubes. There's some terminology here that we need to work on. And so that's what we're going to do right now. So the word faces, oops, I didn't mean to, I meant to highlight that. Let's try that again. Highlight the word faces. Faces have to do with the flat sides of a three-dimensional figure. So this top is a flat side. It has another parallel face to it that's along the bottom that you can't really see. It's there, but it's hidden. So that's two faces right there. Then this front face is the one facing us, has a parallel side on the opposite side that again we can't really see. So that's two more faces. And then there's this side face that has a parallel side across from it. So that's three sets of opposite parallel faces. So all together, that gives us six faces. Okay. The shape of the faces in this particular cube, they are all squares. Now, edges happen when, let me get a good color here. An edge is what happens when two faces meet. So if you take the front face and the top face and they meet right here. And that dark line is called an edge. So let's think a second about how many edges this cube would have. So 1, 2, 3, 4 along the top, which means on the bottom there are also 4. 2, 3, 4. So that's 8. And then we have along the sides. So that would be 12 edges. All right, and then the last thing we want to think about are the vertices. Now, a vertex is where two edges meet. They kind of form a corner. So this, wherever the two edges meet, would be considered a vertex. So I'm going to just draw little circles on the vertices. So there are 4 on the top of this cube, which means there are also 4 on the bottom of this cube. I'm having trouble getting there because I got stuff in my way. So that would be a total of 8 vertices. Okay, and we call this a cube when all 6 faces are squares. Okay, what's this one now? This is a kind of a common figure that you find around in the world. You can see there's an example of a building here and a box that are in this shape. And we call this, well, let's talk about what it's made up of, and then we'll talk about what it's called. Okay. So let's count the faces. So we'll use the highlighter. We had the top face with its opposite bottom face. So that's 2. We have this front face that's facing us with its back side that's opposite. So that's 4. And then we have sort of the 2 ends. So that gave us a total of 6 faces, which was just like the cube. Now, the difference, though, is that the faces are different shapes here. So let me just erase this. Let's think about the shapes of the faces. Well, you can see that this face in the front is in the shape of a rectangle, right? Which means its opposite face is also a rectangle. And the top appears to be a rectangle also. So we have 4 rectangular faces. Now, the ends, though, look like they're squares. Now, it's hard to tell precisely, but I'm going to say that they're squares. Now, the 2 ends are going to be considered the bases, and that's different than the word base that we use when we were finding area 2-dimensional figures. This base, we're going to consider a capital B as opposed to a lowercase b. This base is sort of what the figure might sit on. So when there are 2 of them, they're going to be the same shape. Okay, so in this case, the squares are the base, and all the rest of the faces are rectangles. So we have 4 rectangle faces and 2 square faces. Okay. Now we'll get to why that's meaningful in a second. All right, let's count the edges. The edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. This is just like on the square. Do you think the vertices will be the same as the square? Let's try 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. Yes, they are the same. Sorry, my handwriting's not great. Okay, so when we have rectangle faces on the faces that are not the base, we call that a prism. So this is called a square prism because the base shape is a square and the other faces are rectangles. That's why it's called a square prism. All right. Now this figure looks different for sure. Okay, so let's start with counting the faces. All right, so I see it's sitting on the bottom on a rectangle. Do you see that? And then it appears that there's triangle faces, and I see one there, and I believe there's one opposite it, and then there's one here and one opposite it. So I count 4 triangle faces and 1 rectangle face. So that would be a total of 5 faces. And there are 4 rectangles. No, sorry about that. 4 triangles. 4 triangles and 1 rectangle face. Okay. All right, so now let's count the edges. Well, I can see along the base there are 4 edges, right? And then from the base up to this point, on each of the triangles, there's an edge. All right, so we had 4 along the bottom, and it looks like we have 4 on the triangles. Did we get them all? So 8 edges. And then vertices, we have 1, 2, 3, 4 along the base. And this one that they all meet at the top. So we have 5 vertices. All right, so what was different here? We're going to call this rectangle the base. That's what it sits on. So that rectangle face is going to be part of the name because the base shape is always part of the name. So we're going to call this a rectangular. So we sort of change the word, we add ULAR. That sort of makes it an adjective. And then because the other faces are triangles, this is a pyramid. So we call this a rectangular pyramid. Okay, so the difference between a prism and a pyramid is a prism has rectangle faces in addition to the bases and has 2 bases. A pyramid has triangular faces with 1 base. That is the difference. All right, so this is a cone. We're not going to spend a lot of time on cones and cylinders and spheres, but they have a base that is a circle. And so you can see the circle base here, and then it comes up to a point, and that point is called a vertex. And all of this is just one edge, one face, the rounded part, okay? All right, so now let's look at what else we had here. So we talked about the cone. We know that that's a cone. We know that this is a rectangular pyramid. Pyramid. We know this is a cube. We said this was a rectangular prism. And then some of these other figures you probably recognize. This is a cylinder. I can't write with red on that. This is a cylinder. This is a sphere. E-R-E. And then this last one is, you see that there are triangle faces, but the base is also a triangle. So we call this a triangular pyramid because the faces, other than the base, are in the shape of triangles. Okay? All right, so today's assignment is to look for actual 3-dimensional objects in your home. So what I'd like you to do is to take photos of 3-dimensional figures and name them and put them into a PowerPoint. Send me the PowerPoint on Google Classroom. I'd like you to find at least 5 different solid figures and include them in your PowerPoint, okay? All right, so that is it for today. Have a great day, and I'll talk to you soon.